So therefore we put a symbol dot like this. There is one method of showing that one. So this should be replaced with an equivalent coil. Let M be the mutual inductance between them. I'll show for flux aiding, then what happens, flux opposing, you work out on your own. So I'll send a current I. Let me apply a drop, VE or V naught, any other symbol you can apply it. So let me take V naught. So let the current here be I1, let the current here be I2. Okay, how to find out the effective, how that mutual inductance has to be taken care of. Any method, because M should be M should be brought into the picture. That's what he's saying. Now what is the drop across the inductor? Because they're parallel, they should have same potential difference. So that V0 should be equal to V1 plus V2. I'll begin like this. The first V0 equal to V0 equal to V1 equal to V2. So what is V1? V1 should be L1 di1 by dt. Negative signs I'll just taking out. M di2 by dt. There'll be, due to current I2 flows due to mutual induction, M di2 by dt is what EMF induced in the first coil, and due to varying current in the I1, L1 di1 dt will be EMF induced. So what is the net EMF induced in the first coil? L1 di1 by dt plus M di2 by dt. This is the equation 1, you write it. Similarly, what is the expression for V2? L2 di2 by dt plus M di1 by dt. And as they are parallel, V1 equal to V2, so equating 1 and 2, di1 by dt plus M di2 by dt. So let me bring L1 minus M di1 by dt, L2 minus M di2 by dt. I'll call this as equation 3. Let me substitute the value of di2 by dt, di2 by dt or di2 by dt in equation, okay, this is which one? Yeah, equation 3 we'll call it. So what we have to do, so here what is the equation? Again it will be like this, no? V0 should be equal to L di by dt, and that has to be replaced here. So I'll put 3 in 2. So V2 is equal to L2 di2 by dt will be L1 minus M no. Actually, they're parallel. The magnetic field produced by this solenoid will be inductor, that one. It's not that inductor means always need not be solenoid. It can be any other thing. it can be any other structure. So altogether it have a self-inductance. I just brought in the form of shape of solenoid. Say I'm going to wound in such a way that it will be like this. In that case, what you do? It can happen like this, no? So fine. So don't say mutual inductance 0, that one. I can wound coils in such a way that mutual inductance will be there and they're parallel. So this, after simplification, this will be L1 L2 minus L2M L2 minus M plus M di1 by dt. So further simplification of this, V2 is equal to L1 L2 minus L2M will get cancelled. So let me write directly one equation looking at that. M square by di1 by dt. So this is the value of L1 L2 minus M square by L2 minus M di1 by dt. So what is di1 by dt? So I got the value for this. This should be equal to L2 minus M so this is V2 equal to V0, no? This is V0. Let me keep V0 here. So call this equation 4. I think now. So I got di1 by dt. After getting di1 by dt, I can solve for di2 by dt. So whose help? I'll take help of equation 3. Putting 4 in 3, we'll get expression for di2 by dt. Put 4 in 3 and solving di2 by dt. L2 minus M will get cancelled, no? Anybody value? L1 minus M yeah, fine. It'll be this much. Okay, there's the equation 5. Okay, now I know di1 by dt, di2 by dt. So I'll proceed to the next step here. These two coils I'm going to replace with an effect to this one. So what is I should be equal to I1 plus I2. So this I should be equal to I1 plus I2. Next step. Try to see this. So what is I? I is equal to I1 plus I2. So I'll di by dt equal to di1 by dt plus di2 by dt. We know di1 by dt, di2 by dt value. So looking at this, what is V0? V0 should be equal to L di by dt. And di by dt is sum of these two, di1 by substituting di1 by dt in the equation 5 and 6. So like, what all we have? 4, 5 and 6. V0 will get eliminated. We'll get L in terms of L1, L2 and M square. I'll directly let me write. Put 4 and 5 in 6. Solving that, I'll end up with equation L1 L2 minus m square L1 plus L2 minus 2m. This is what when flux is aiding. You have to remember this formula. Nobody will ask you derivation. If I write directly, you'll find you can't accept answer. You are asking us to memorize. There's a method. Why I'm showing this method is finding out the effective inductance is not that easy. By means, if I just change the orientation of this coil, instead of this vertical, let it be like this. Then what when things will be very complicated. So therefore, finding out self-inductance is finding out effective inductance is very complicated. Why very complicated? Why very complicated? I'll tell you. So if you have a circuit like this, I'll ask you to find out self-inductance between A and B. I think it's a big headache. How you calculate this? We have to use the similar procedure. They're not, so this angle orientation also you have to consider. How this particular like a structure is kept, no? The solenoid, its orientation also you have to consider. Again, there'll be mutual inductance between them. Again, there'll be mutual inductance. Of course, they're 90 degree, okay. Then mutual inductance, mutual inductance. I think you need 1 or 2 days to calculate this. And we have to write equations mathematically, then we have to bring it. So you don't get big circuits where 2, 3, 4, 5 inductors, then effect of mutual inductance. Really very difficult. It's not possible. For 2 inductors only, see how much I struggled. Again, the orientation of inductors, slightly this, if its orientation changes, no, again, the problem is totally different. Like this. So therefore, just stick on to the basic formula I just shown for one. This is for flux aiding. Now we'll get also flux opposing. Flux opposing means how do we show it? Say how means the solenoid there, the turns are owned in such a way that B bar in both the solenoids will be in same direction. Then only this side to be, means the B bar, the lines of force of this will be in the direction of this one. Means how B bar should be in both the loops should be opposite or same direction. The lines of force generated by one should be in the direction of other one. And we know that lines of force will come like this, no? Here. Will come the lines of force, and the lines of force of this will come. So these lines of force should be directed in the direction of lines of force for this one. That's why it is called as aiding. That will show by a dot. Okay, let's similarly, when the flux is opposing, slightly we'll modify the formula. You have to remember this formula, very important. We do have some applications based on this. We'll put dot like this to show that flux is opposing that one. Here, flux opposing. Then the self-inductance of this will be L1, L2 minus m square, L1 plus L2 plus 2m. Or you can proceed in the similar way what we did earlier. Books, they're given plus or minus sign, they didn't say for which one it is. Opposing numerator, denominator plus, flux aiding the numerator, this will be negative sign. Similar way what I did, you can proceed in that particular thing. So just do remember, I think this will be sufficient. Now this is, if there is no mutual inductance between them, I'll block the flux linking from one coil to other coil. In that case, it will be simple formula, like similar to resistor. 1 by L equal to 1 by L1 plus 1 by L2 with mutual inductance. Now, sir, if there are 3 coils are there and there's mutual inductance, the problem will be very complicated. formula will be totally complicated. Mutual inductance between 1, 2, between 2, 3, between 3, 1. So you need 3 mutual inductance has to be introduced when solving. It is, if you refer some any electrical books, no, that's available. We have a formula to generate. So at our level, okay, we'll try to avoid it.